Dr. R.K. Radha, Assistant Professor, Department of Statistics, Presidency College, Chennai. She has done her PhD in statistics on a novel approach for prior selection in Bayesian modeling. She has 27 years of teaching experience, has guided 4 MPhil students, published 5 articles in national and international journals, has attended 10 conferences in India. She had given training for staff at Tamil Nadu State Statistical Training Institute, Department of Economics and Statistics.
Welcome to UGC lecture series on mathematical sciences. Today we are going to talk about confidence interval under statistical inferences. Already in your earlier classes we have discussed confidence interval for difference between the means and confidence interval for the parameters of the normal population, namely mean, that is mu, and variance sigma squared. In today's class, we are actually going to discuss about the confidence interval for the ratio of the two population variances. So, coming to the theoretical part, if x1, x2, etc. up to xn follow normal with mean mu and variance sigma squared, and if y1, y2, etc. up to yn follows normal, it has mean mu and variance sigma y squared. Both these samples are independent, then we know that n minus 1 sx squared divided by sigma x squared follows chi squared with n minus 1 degrees of freedom. And similarly, for the second sample, m minus 1 sy squared divided by sigma y squared follows chi squared with m minus 1. So, here first sample has got n samples, second sample has got m samples. Therefore, by independence of two samples and by the definition of f random variable, we know that f statistics is nothing but it is the ratio of the variances. So, here you have s squared y divided by sigma squared y divided by n minus 1 sx squared divided by sigma x squared. The ratio of the variances has to be divided by its corresponding degrees of freedom. Therefore, here it is m minus 1 and here it is n minus 1. Therefore, f statistics is nothing but sigma squared with respect to x, sigma squared with respect to y into s squared y by s squared x follows f distribution with f minus 1 comma n minus 1 degrees of freedom. Now, our objective is to find out 100 into 1 minus alpha percent confidence interval for the ratio of the variances. Therefore, by definition of confidence interval, you consider probability of f of 1 minus alpha by 2 m minus 1 n minus 1 degrees of freedom, which is less than or equal to sigma squared with respect to x divided by sigma squared with respect to y, and here it is the population variances s squared with respect to y, s squared with respect to x, which is less than or equal to f alpha by 2 m minus 1 comma n minus 1. So, here we have considered 1 minus alpha by 2 and alpha by 2 because of the construction of our distribution of the f. Therefore, here our objective is to find out the ratio of the variances. So, to find out the ratio of the variances, multiply either side by this particular term, or you can divide it by s squared x divided by s squared y. So, here doing that particular operation, you will get in the following form, namely that probability of 1 minus alpha by 2 into m minus 1 n minus 1 degrees of freedom into variance with respect to x, variance with respect to y is less than or equal to your ratio less than or equal to alpha by 2 m minus 1 n minus 1 s squared, that is your population sample variances s squared x divided by s squared y, which is equal to 1 minus alpha. Therefore, 100 into 1 minus alpha % confidence interval for the ratio of the two population variances reduces to this particular form. Now, an important factor is that f of 1 minus alpha by 2, for problem's sake, you can write it as 1 divided by f of alpha by 2 n minus 1 m minus 1 into sample variance of x, sample variance of y. Similarly, here it is f alpha by 2 m minus 1 n minus 1 sample variance of x and sample variance of y. The reason for writing f of 1 minus alpha by 2 is equal to f of alpha by 2 is for the computational purpose, that is to refer our f tables. So, here let us look into the problem how to get the ratio of the variances. So, let us go for the problem. Time taken by workers in performing a job are given below. Two methods are considered. Method 1, your values are given as 20, 16, 26, 27, 23 and 22. Under method 2, 27, 33, 42, 35, 32, 34 and 38, and you find that n1 and n2 are not the same. You have to estimate the variances. So, here estimate with 95% confidence the ratio of the two population variances. So, here the first step is to calculate the variance of the samples. So, here I have got the list of the first sample, namely that method 1 is my first sample. So, here method 1, the values of x are 20, 16, 26, 27, 23 and 22. So, 134 is nothing but the summation of x. Now, I would like to take the deviation about 22. So, when I take the deviation about 22, my d is nothing but minus 2, that is 20 minus 22 gives you minus 2, 16 minus 22 gives you minus 6. So, proceeding in the similar manner, you fill in the column, you will get the total as 2 for summation of d. Square it out, therefore, you will get it as 4 square d. So, minus 2 the whole square will give you 4, minus 6 the whole square is equal to 36. Proceeding in the similar manner, you will get your summation of d squared, which is equal to 82. Now, once again go for the method 2, which I have taken it as the sample 2. So, method 2 values are 27, 33, 42 etc. So, adding up the row, you will get summation y equal to 241. Now, in the next column, take the deviation about the value 34. So, here you will get 27 minus 7, which is minus 7, 33 minus 34 is minus 1. So, proceeding in a similar manner, you can fill in all these columns. You find summation of d is nothing but equal to 3. Now, in the last column, you have to square it, that is minus 7, d you have got it as minus 7. So, d squared is 49. Here it becomes 1. So, proceeding in the same manner, you find the total, that is summation of d squared is equal to 135. So, you have filled in all the data. Now, from the table for the first sample, that is for the method 1, your x bar, formula for x bar, you know that it is nothing but summation x by n. So, here n is nothing but the size of the first method, which is 6. From the previous table, you have got summation x is equal to 134. So, 134 by 6 gives you 22.33. Now, go for the method 2, which I have denoted as y bar. So, here it is nothing but summation of y. From previous table, my summation of y is 241. So, 241 divided by 7, which is 34.5. 0.43. Now you have to estimate the sample variances, which is nothing but your sample variance is summation of d squared by n minus d bar, where your d bar is nothing but summation of d divided by n. So go to the previous table. So here you have got summation of d is equal to 2. So here d bar, I have said it is summation of d, which is equal to 2. Number of the sample for due to the method 1 is 6, so it becomes 6. Next, here it is summation of d squared. So summation of d squared from the previous table is 82. Therefore here you will have 82 by 6. So substituting and on simplification you will have the value as 13.23. Now go for the method 2. Method 2, for the method 2, your sample variance again is nothing but S2 squared is summation of d squared divided by n minus of d bar. So here d bar is nothing but again summation of d divided by n, but here you have to consider for the second sample. So for the second sample, my summation of d is 3. I have substituted here as 3. Size of the sample is 7. Next, you have to go for summation d squared. So summation d squared is nothing but 135 for the method 2, that is for the second sample. So 135 by 7. On simplification, you find it is nothing but 19.11. Now actually you need to find out your S1 squared, where S1 squared is nothing but the unbiased estimate of the population variance. Hence S1 squared can be calculated as n1 S1 squared divided by n1 minus 1. Therefore for the method 1, you know that your size of the sample is 6. S1 squared you have calculated as 13.23 divided by size for the first sample is 6. So 6 minus 1, 5. On simplification you will get 15.88. Now go for the method 2. As before, find out the sample variances, that is with respect to the population. So it becomes n2 S2 squared divided by n2 minus 1. So here for the second sample, your n2 is 7. You have already found out what is your S2 squared. S2 squared is nothing but sample variance is 19.11. So substitute here. N2 for the second sample is nothing but it is 6. So 6 minus 1, which is 5, on simplification gives you 22.30. Now n is nothing but the first sample, which is equal to 6. Let me denote m for the second sample, which is equal to 7. Now let us see what happens. So here 100 into 1 minus alpha % confidence interval for the ratio of the population variances is given by 1 divided by f of alpha by 2 n minus 1 m minus 1 S1 squared by S2 squared f alpha by 2 m minus 1 into n minus 1 S1 squared and S2 squared. Now in F statistics is very important that you have to go and check for the variance with respect to the population, that is the unbiased estimator of S1 squared and S2 squared. Here when you take S1 squared, value is nothing but 15.88. When you take S2 squared, the value is 22.30. Always F ratio has a condition saying that your numerator value, that is S1 squared and S2 squared, if you consider, numerator should be always greater compared to the denominator. But in this case, here you find that numerator value, that is S1 squared, is lesser compared to the second sample. So that is what I have written here. S2 squared is greater than S1 squared. So in such a case, the rule says that you have to interchange the variances. So you also have to note that you have to interchange the degrees of freedom. That is, here in your F table you will have greater mean square in this direction and lesser mean square along the vertical direction. So, when you look into the normal F tables, you have to first look into the greater mean square and then the lesser mean square. Hence, it is important that your condition for the S2 squared greater than S1 squared or S1 squared greater than S2 squared is important. So, in this particular problem, you find that S2 squared is greater than S1 squared. Therefore, using that condition in this particular formulae, it is F alpha by 2. I said that the corresponding degrees of freedom also gets interchanged. So, you will have m minus 1, n minus 1, S2 squared by S1 squared, and here F alpha by 2, n minus 1, m minus 1, S2 squared by S1 squared. So, substituting the values, I need to find out 95% confidence interval. I have to estimate at 95%. Therefore, 1 minus alpha is equal to 0.95 implies alpha is nothing but 5%. Therefore, my alpha by 2 is going to be 0.025. Hence, I have to find F alpha by 2 with an appropriate degrees of freedom. That is, here the numerator degrees of freedom and here the denominator degrees of freedom. So, here F alpha by 2 can be looked into the F tables with 0.025. So, on looking that, here you will have n minus 1. So, here I have said earlier that my n is going to be 6 and m is equal to 7. So, n is equal to 6 and m is equal to 7. So, here you will have 1 by f of alpha by 2, that is 0.025 with 6,5 degrees of freedom into S2 squared by S1 squared. Here it is going to be f 0.025 with 5,6 degrees of freedom into S2 squared by S1 squared. Looking into the normal tables with an appropriate degrees of freedom, you find that 5.99 will be the value of f 0.025 with your 5,6 degrees of freedom, and here 6.98 will be value of f alpha by 2, that is f 0.025 with 6,5 degrees of freedom. So, here you have already found out your S2 squared, S1 squared, S2 squared and S1 squared. Take the ratio, then multiply with 1 divided by 6.98, you will arrive at 0.201187. Similarly, here 5.99 into the 22.30, 15.88, you will find that you are getting the value 8.41165. Therefore, you have found out for the method 1 and method 2 that their variance lies between 0.20 to 8.4. So, hence we have obtained 95% confidence interval for the ratio of the two population variance, and we have found out the values to lie between 0.20 and 8.41165. Now, we have few important note to be noted is that the interval contained the values 1, that is, here the interval ranges from 0.20 to 8.4. So, somewhere here you will have the value 1. So, the interval contains the value 1. Hence, based upon that, we cannot conclude that the population variances differ. Okay. So, this is a striking note regarding this particular problem. So, coming back to the summary, So today's class we have learnt about the ratio of the two population variances. So in other words, we have to use your F test to find out the two population variances. Here we need to estimate the variances, that is your Sx squared, Sy squared, or S1 squared and S2 squared, namely that the sample variances with respect to the population, and you have to compare the values obtained S1 squared and S2 squared, check whether which is greater. So remember in your calculations that always your numerator should be greater than the denominator, so that your F value will be always greater than 1. If not, interchange it out and interchange also the appropriate degrees of freedom and get the table value, draw the inferences, and hence you can comment upon the ratio of two population variances either at 99% or 95%. So now I have got few questions for you. So here first question is that obtain 100 into 1 minus alpha percent confidence interval for the ratio of two population variances. So it becomes necessary for you to define an F statistics, then create the confidence interval based upon the F statistics, substitute the values of F and draw the conclusions so that you will get your ratio of the two population variances. Second question is that if F is less than 1, then what will be the F statistics? As I have said in my summary and in my working out the example, that if F value is less than 1, you cannot proceed with the problem. Hence, it is necessary for you to make F value greater than 1. So, to make this value greater than 1, I have said that F statistic should consist the numerator value greater compared to the denominator value, that is your variances, namely that Sx squared or S1 squared, that is depending upon the sample, then Sy squared. So here F Sx squared should be greater than Sy squared. So here if F is less than 1, you will have Sx squared is less than Sy squared, for which you cannot go and proceed, because the simple reason is that the F value should be always greater than 1. Hence, you need to interchange the value and to draw the conclusions. Third question, you have got two independent random samples x and y are given as follows. The values of x are 55, 56, 57, 58, 65 and 42. Y values are 65, 72, 83, 42, 61 and 82. You have to obtain 99% confidence interval for the ratio of the population variances. So in this particular problem, I have given a case where my sample size is equal, that is your N1 and N2. N1 is the size of the sample X, N2 is the size of the sample Y, and which is equal to 6. So here to obtain 99% confidence interval, you need to find out what is your Sx squared, Sy squared. So from Sx squared, you find first small x squared, that is your sample variance. Having obtained sample variance from S1 squared and S2 squared, find out what is your capital S squared and capital Sy squared. So having obtained this, check the condition, namely that Sx squared is greater than Sy squared. If not, interchange. Find out 99%. So here alpha is nothing but 1%, that is 0.01. So alpha by 2 is nothing but 0.005. So either you have to find out, refer to the F table for F alpha by 2, that is 0.005 with 5,5 degrees of freedom. So here you will be finding out 1 divided by F of this particular value into capital S x squared by capital SY squared, comma F of capital Sx squared by Sy squared. So that will give you the 99% confidence interval for the population variances. So you know how to calculate S1 squared. S1 squared is nothing but either you can take the deviation, namely that for x you can take d is equal to x minus 57, find out summation of d squared and calculate d bar. Therefore, your S1 squared is nothing but summation d squared by S1 squared is nothing but summation d1 squared divided by n minus summation of d divided by d1 divided by n. Similarly, repeat this operation for S2 squared. For S2 you can take namely that d is equal to say y minus of 42. So having obtained these values, substitute. If you fit in, you will get your 99% confidence interval for the population variances. Try it. Thank you.